Okay, well, welcome back. We're in 5-2, which is direct variations. Okay, our objective for today is going to be to write and graph direct variation. Okay, so A1.2.1 is our standard, A1.2.3 is our other standard we're going to be talking about today. Okay, so what is a direct variation? A direct variation is the basic of linear equations. Okay, it's represented by an equation called y equals kx. The biggest thing I want you to know is what is the constant of variation. Okay, we'll be able to work out through direct variations really easy once we get in slope-intercept form. So constant of variation is represented by the letter k. This is basically just saying the slope. Okay, so we're just going to represent it as the slope, basically, is what we're saying. So let's look at how to identify. Now, the biggest thing we have to know is that direct variations follow this model of y equals kx. This is what all direct variations look like. It's simply a multiplication problem of k times x, and then it equals y. 1y more importantly. So let's verify if a is a direct variation. Well, I want it to be y equals, so the first thing I have to do is divide by 7. When I divide by 7, I get y equals 2/7 x. Well, there is no plus anything, it's just a multiplication problem, so this is, yes, a direct variation. They want to know what is the constant of variation, which is basically what is just the slope, what is the k. Alright, so the k in this case is 2/7. So there is my answer. It is a direct variation, and my k is 2/7. Well, let's look at part B. Again, we want it to be y equals, so I need to subtract 4x. I'm going to do that to both sides. I get 3y equals, and I'm going to put the 4x first, just for getting used to it, because we're going to see it that way. Negative 4x plus the positive 8 was there. And then I'm going to divide by 3 because everything has to be divided by 3 to get y equals. And that becomes, as two fractions, a negative 4/3 x plus 8/3. Now the part that makes things not work in this case is that we have this plus 8/3. It's not just the kx. Right here's the kx. Okay, but we have an addition. So this one would be a not direct variation. Okay, so it's not. Let's go ahead and look at part got it number 1. I want you to go ahead and do that on your own. Again, it has to be that formula, so I would write that down first thing. Y equals kx. It has to be of that format, so be very, very cautious with this one. Okay, let's look at problem 2. Problem 2 is asking us to write the direct variation. So the first thing I'm going to do is write down y equals kx. We want to write that formula. Well, since I told you k is basically saying slope, let's go back and let's talk about what slope was. In the last lesson we said slope was the change in the y over the change in the x. Well, direct variation is real simple because it's always the same going through. Since it told us what is the direct variation, so implying that it is a direct variation, okay, all we need to know is what is the y over the x. So they gave us 35 as our y, and we take that over the x, which they gave us as 5. So we know that 35 over 5 is 7, which is my k. So basically all I have to do is take the x and the y they gave me, put them over each other, and there's my k. So what's my equation? Well, my equation is y equals 7x. There's my equation. Okay, so that's it. I'm done with that part. It says, what is the value of y when x is 9? Now you can do this two ways. One, you can plug in 9 and solve. The other way is you can set up as a proportion, because direct variations are proportions. That's really what it is. So we take 35 over 5, set that equal to, well, we want to know the y over 9. And then all we're going to do is cross multiply. Okay, just cross multiply and solve for y. Any way you do it, you're going to get 5y equals 9 times 35, divide by 5, Simplify that by taking 9 times 35 divided by 5, and you get 63. So my answer is 63, or plug in 9 here. 7 times 9 is 63. So if you didn't really want to know what the equation was, proportions would be how you do this problem. You just say, here's y, here's x, here's an unknown y, here's a known y, or x. You put y over x, and cross products, proportions. If you want to set up the equation and then solve, then you do x, the y over x, get your k. So you have two options there to go through. If it's just asking for the y, I would go proportions. That'd be the quickest. So here's an example. Represent the equation and then solve for y when x is 12. Go ahead and do that one on your own. Okay, let's talk about how to graph these. Graphing these are very, very simple. So I'm going to do part A. I want you to do part B. But how am I going to graph these? Well, I'm going to start by picking some values. So I'm just going to start basic. Let's go ahead and pick like -3. I'm going to pick 0 and let's say 2. I'm just going to plug them in. So I'm going to say y equals, I'm going to take my 3 times the -3. Well, when I do that, 3 times -3, I get -9. So I go back 3, 1, 2, 3, and I go down 9 units. There's my first coordinate. Well, I'm going to do the same thing, but now I'm going to plug in 0. Well, that's real easy. 3 times 0 is 0. So there's my next coordinate. And then I'm going to go back through and I'm going to pick another value, let's say 2. And 3 times 2 I get 6. So I go 2, and I go 1, 2, 3, 4, 5, 6. And there's my coordinates. I got 3 points. You need a bare minimum of 3 for this section. Draw my line, and bingo, there is my graph. That's it. I mean, you just have to pick at least 3 coordinates, and it's just plug and chug. Pick your x, plug it in there, and solve. Use parentheses like I did here, because what you want to do is you want to be able to write it and multiply. Okay, so those negatives, if you don't write it, you might say 3 minus 2 instead of multiplication. Okay, go ahead and do part B on that last one. Let's talk about writing direct variations from a table. Now the biggest thing here is, again, we said k was equal to our slope, which our slope is the change in y over the change in x. Okay, so basically, as I said, k is, let me rewrite this, k is the y over the x, as we did in the proportion problem. Okay, it is proportionate. So what I need to be able to say is that 6 over 4, which is my y over my x, is equal to my 12 over 8, which is equal to my 15 over 10. As long as I do that for each one of these and it comes out to be equivalent, then it is proportionate. Well, 6 over 4 is roughly 1.5, or it is 1.5. 12 is over 8 is 1.5, and this is 1.5. Okay, so as we go through, they're all 1.5, so my equation is y equals 1.5x, or 3/2 x if you write it as a fraction. That's it. So make sure, though, each one of these are. Say that this was 8 over 11. This one will work, this one will work, but the middle one would not. So therefore, it would not be a direct variation. So go ahead and do part B. Again, y over x, y over x. Okay, so that's really it. Direct variations are very, very simple. Direct variations are always going to be y over x ratio is your constant of variation, which makes up your equation. Y equals that y over x value times x. That's simple. If you have questions, we'll go over it tomorrow. But that's it for today.